All right, Mr. Ahmed here for 10.1 part 2. Goal for today is just to go over a couple example problems and one definition. The one definition is a common tangent. And a common tangent is a tangent line or segment that is tangent to two coplanar circles. So for these two circles, a common tangent would be tangent to both of them. So if I were to draw a line right here on the bottom part outside, which is an external tangent of the two circles, and it's tangent to both. Now my line's not perfectly straight. I did my best there. These 2 points are both points of tangency. Therefore, this line is a common tangent. I'm going to take out a straight edge here to try and draw the next one a little bit straighter if I'm able to locate one. All right. Apparently I lost my ruler, so I guess I'm just going to keep freehanding these lines. So on the top, these 2 points of tangency, if I can connect the one line, this would also be a common tangent between the two circles, also outside, so that is an external tangent. And therefore, this thus far has 2 common tangents, but I can still draw a few more. If I were able to draw a line inside in between these 2 circles, I can also create a common tangent. So I'd kind of fly in from like, here to here. And I could also do one more going the other direction, from here-ish to here. So this has 4 common tangents. All right, on the next part, we are supposed to determine if SR is tangent to circle T. So for SR to be a tangent to circle T, this angle R, has to be a right angle. And for us to check that, we have to use the converse of the Pythagorean theorem. We have to see, is C squared equal to A squared plus B squared? So the hypotenuse, the longest side, has to be 11. Is 11 squared? Is that equal to 8 squared plus 4 squared? So we'll do a double check here. 11 squared is 121. 8 squared, 64 plus 16. And 64 plus 16 is not going to quite get us there. We're going to be a little bit too small. 64 plus 16 is 80. 121 is not equal to 80. Therefore, SR is not a tangent. If these would have been equal, it is a tangent. It has to be a right angle. Since it didn't satisfy Pythagorean's theorem, we cannot state that it's a tangent. And finally, one of these harder problems with the radius. All right, so in this case, this is a right angle. We are assuming this is a tangent, and circle Q. And the hypotenuse in this case is not 18. The hypotenuse is 18 plus r. So when I set up Pythagorean's theorem, I have to do 18 plus r squared equals r squared plus 24 squared. Now when I solve this, the key here is I have to FOIL this. I cannot do 18 squared plus r squared. That's not a legal move. I have to rewrite this as 18 plus r times 18 plus r. And when I FOIL, I distribute the 18 and I distribute the r. So 18 times 18 is 324. Then 18 times r is plus 18r. Now I distribute the r. R times 18 is also plus 18r. And r times r is r squared. And that equals r squared plus 24 squared is 576. Now for us to solve this, notice I have some r's and I have some r squareds. Now I'm going to draw this line for this equation just to kind of notice that I have an r squared on both sides. So when I subtract r squared, we get lucky, they cancel. I don't have to solve a quadratic. We will see some quadratics popping up throughout this chapter, but this isn't going to have to be one of them. Then when I combine my like terms, 324 plus 18 plus 18 is 36r, and that's equal to 576. And then from here I can subtract my 324 from both sides, and I get 36R equals 252. Subtracted 324 from both sides. And then we just have to divide, and R is equal to 7. So we will see a couple of those. All right, that's it for today. Have a good one.